Assalamualaikum warahmatullahi wabarakatuh and good day. Alright, so today we continue our lecture with the application of partial derivative. Right, so in this course you will learn I will introduce you to the first two application of partial derivative where you can find a small increment and the rate of change by using partial derivative, right? But first, let us see what is the notation used to denote a small increment, right? So the small increment will be denoted by using this symbol, okay? So if you see this symbol, okay, it will referring to a small increment, right? So other name for small increment, okay, sometimes we also call it error. So error is one of a small increment of a function. Okay, let us assume that you have function z, while z is a function that is depending on few variables. Okay, so it depends on more than one variable. So x1, x2, x3, and so on until xn. So we don't know. It can be 100, it can be 2, it can be 3, 4, and 5, right? So just let us assume that this function as z. Okay, in order to find the error or small increment of this function or function z, we'll be using this formula. Okay, where the small increment in z is equivalent to, okay, partial derivative of each variables you have. Okay, so you and then multiply with the small increment of the respective variable. Okay, so if you have function f which is depending on x, y, and z, okay, you need to partially differentiate with respect to each variables here. Okay, so in order to find, let us assume this equal to z. If you want to find the increment or the error in function z here, okay, this is equivalent to you differentiate. Okay, so partially differentiate your f or your z here because we denote your function f here with z. So partially differentiate your z here with respect to x first. Okay, so you will assume y and z in the function as constant and then multiply with the increment of the respective variable. So the respective variable is x, so you find the small increment of x. Okay, it won't stop here because you have 3 variables, so continue with other 2. So partially differentiate your z with respect to the second variable which is y, multiply with the increment, okay, of the y, the respective variables. And then the last one plus with partially differentiate your z with respect to z. Okay, I need to use different letter here. We use w because we have assumed this as z, right? So w with respect to w, and then multiply with the increment of that respective variable which is w. Okay, so sum all of this multiplication of the partial and the increment, you will get the increment for the whole function. Okay, so if you have more than 3, this summation will continue. Okay, that is for a small increment. Besides finding a small increment, you also can find the rate of change of your function with respect to time, right? Usually, when we say rate of change, it will involve with time. Okay, means you will differentiate your function with respect to time. Okay, so this is certain. So we write D. We use symbol dz dt. Okay, this is a very certain where we just differentiate the variable with we differentiate the function with respect to one variable, which is t. So we will use symbol d for the differentiation. Okay, we use symbol del here. Okay, when we want to find when we partially differentiate the function with respect to few variables. Okay, so you'll be using this formula in order to find your dz dt. Okay, rate of change of function z with respect to time, and the formula is same as you do for small increment. You need to partially differentiate your function with respect to each variables that you have. If you have two, so 2 times of partial derivative. Okay, and then you need to multiply with the changes of the respective variable with time. So you'll be using this formula, right? So this is for rate of change and this is for the increment. Okay, now let us continue with the first example here. The measurement of closed rectangle. So you have a rectangle. This should be highlighted. You have a rectangle. So you must have the imagination of rectangle in your head. Or to be easy, so just draw the rectangle. Okay, so rectangle so that you can label this letter. So okay. So this is your rectangle. Okay. It has length x equal to 5. So the length x equal to 5 meter and the width, which is the y, is equal to 3 meter. So the width, which is this one, this is equal to 3 meter. And the height, which is the z here, okay, this is your y kan, this is your y, this is your height, which is your z, is equal to 3.5 meter. Okay, so you have the length, you have the width, okay, which is y, and you have the height, which is 3.5. Right, so can you imagine that? Right, so with a possible error of plus minus 1 over 10 cm. So 1 over 10 cm is equivalent to plus minus 0.1 centimeter. So each of these measurement, your x, your y, and your z, it will have plus minus 0.1 error centimeter. Okay, look at the unit here. Please be careful. You have meter, meter, meter. While for the error given in centimeter. So you need to convert to a standard measurement, okay, standard length, where since you use here meter, most of the information used in meter, so convert 0.1 centimeter to meter, so this will be equivalent to 0.001 meter. So this is the error. Okay, so each of these x, y, and z here has a plus minus 0.01 centimeter, 1 meter error. Okay, right. So what is the maximum possible error in the calculated value of volume and the surface area? So you need to find two things here. First, the volume of rectangle, and the second is the area of rectangle. So find the maximum possible error. Alright, so you need to come up with a formula of volume for the rectangular. So the volume of rectangular, so I just write like this, is equivalent to x times y times the z. Okay, so this is the volume, the formula for volume of rectangular. You need to multiply your length with the width with the height, that will give you a volume. Okay, and the second one, you need the surface area. So the surface area here, you need to calculate the surface area of rectangular. So second one, surface area. So the area of the surface, okay, or the rectangular. What is the formula? Okay, so we have two surfaces of this. You have one at the top here, one at the bottom here, right? So you have two surface of x multiplied with y. Okay, so the surface of that, the surface of this area, okay, the area of this surface, the area of this surface is x multiplied with the y will give you this area, okay, this surface area, right? Okay, so this is the formula, x multiplied with y. Since you have two surfaces, so you multiply with 2 as well. Okay, and then what else we have? We also have two surfaces of this small part. Okay, so this small part is equivalent to z multiplied with y. Am I right? This is your z, the height. You multiply with the width here. So that is x, not x, y multiplied with z. Y multiply with z. Since you have 2, so you need to multiply with 2 as well. Right? So what else do we have? We have this surface. Okay. This small surface. Okay. What is the formula for this surface? You need to find the area for this surface. You need to multiply z with your x. Okay, so plus with multiplication of z with your x. And don't forget, you have 2. Since you have a rectangle here, so you have one more to the other side, right? Okay, so you need to multiply with 2 as well. So this is the area of the surface for your rectangle, which is equivalent to 2xy plus 2yz plus with 2zx. Okay, so you have two formula here to be solved. Okay, and you need to find the maximum possible error, which is the delta z. Okay, or delta of your volume and delta of your area. Okay, so you need to find this. Okay, so we continue to the next slide. Okay, now we will start to find the possible error of the volume. Right, so we have start with formulating the formula for the volume, where we know the volume of rectangular is equivalent to multiplication of x, y, and z here. right? So x is equivalent to 5, okay, z is equivalent to 3.5, and y is equivalent to 3 meter just now, right? Okay, and we know that the possible error, the del, okay, of each measurement here is plus minus 0.001 meter. Okay, all these informations are given in the question just now. Alright, so we have formulated the formula here, right? To so it's just left for us to apply into formula of finding the delta of our volume, where we need to partially differentiate each of these variables, okay, multiply with their increment and sum all the for all the variables. So you have three variables here for x, for y, and for z. So you will have three partial derivative with respect to x, y, and the third one with respect to z. And each of the partial multiply with the increment, okay, the error of each measurement, okay, where it is given, it is equal to plus minus 0.01. Okay, since it asks the maximum error, so we will just consider the positive. Okay, the maximum error, so we just consider positive 0.01. Okay, and we need to first find the derivative, partial derivative of your v with respect to x. So del v with differentiate with respect to x, you will get, differentiate x, you will get 1. So we just left with y and z, because you treat y and z as a constant when you differentiate with respect to x. Okay, then do for y. When you differentiate y, you just concentrate on y and treat the other as a constant. You will get 1 times with xz, so you will get xz. For del v del z, okay, you will concentrate on z, and these two will be constant, so you will get xy. Okay, so apply that into the formula. You have y multiplied with z times with delta x plus with xz times with del y plus with xy multiplied with del z. So you have all the information for all these unknown, right? So this will become, what is your y? Y is 3. What is your z? 3.5. And the increment is all the same for all the length. So x is 5. Z is 3.5. 0.001. Plus with x is 5. Y is 3. And the increment is 0.01. Okay, 0.001. Okay, and then perform the calculation. That will give you 0.043 meter. Okay, so this is your del V, the increment for the overall volume. Okay, next we proceed with the area. Oh, one more thing before I forgot, please take note that the unit for the increment of the volume just now is meter cube, okay, because it's a volume, right? So the answer is 0.043 meter cube, because we have multiplied two sides, x and y, that will give us meter square, and then we multiply again with another unit of meter for the increment, so that will give us meter cube. Okay, the volume, right? Okay, now proceed with the surface area. We have formulated the area for the rectangular is equivalent to the second formula here, right? So to find the increment of the area, we will apply the same formula as we did before, right? So partially differentiate your area with respect to x first. That will give you, okay, so the x this, that will give you 2y plus with x only, right? So you will get 2z. So you don't have x in the third term here, so that will be 0. Okay, so done for x. We now proceed to del A, del y. So for y, we have 1 here, so that will give you 2x. We have no y in here, so this will be 0. So we have 1y here, so that will give you 2z. Alright, so we're done with respect to y. So do for the last variable, which is z. So you don't have z in here, that will be constant, so 0. You have z in here, that will give you 2x. You have z here, so that will give you 2y. Okay, and the same increment for your x, del x, del y, and del z, which is 0.001. So apply into the formula here. Del A is equivalent to del A del x. So you have 2y plus 2z. This need to multiply by delta x plus with del A del y. This is your del A del y. 2x plus 2z multiply with del y plus with del A del z, which is this. So 2x plus 2y multiplied by del z. Okay, so 2y, y is equivalent to 3.3. It's 3, right? So 2 times 3 plus 2 times z, 3.5, times with delta y, which is 0.001, plus with 2 times x, which is 5, plus 2 times z, 3.5, times with 0.001, plus with 2 times 5 plus 2 times 3 times 0.001. Okay, apply that to your calculator. That will give you the answer equivalent to 0.046 and the unit is meters square. Okay. So that is the increment for the area. Okay, let's go to the second example. The radius R of a cylinder. So take note that you'll be having or you'll be dealing with a cylinder is increasing at rate of 0.2 centimeter per second. So rate of the radius. So this is dr dt is equal to 0.2 cm per second. While the height h is increasing at 0.5 cm per second. So the rate of height means that your dh dt is 0.5 cm per second. Then determine the rate of change for the volume. So dV T. When your R is equal to 8 and your H is equal to 12. Now you need to find this. What is this? So you need to formulate a formula of the volume for a cylinder. Right? So we draw a cylinder. It is worth to draw. Right? Excuse my drawing. It's not that beautiful. Never mind. So this is your R. R is 8. And this is your height. Height is given at 12. Okay, so this is cm and cm. So we have the HDT, we have the RDT, and this is what we want to find. Okay, so since it asks for a volume of cylinder, come up with the formula of volume for cylinder. Okay, CY cylinder, which is pi r squared h. Okay, you can find this from your textbook if you couldn't remember this. Okay, this is similar formula as in the differentiation that we performed in chapter 4. Right? Okay, once you have come up with this formula, now you can formulate your dVdt formula, where for dVdt, okay, so here your function is depending on two variables only, which is r and h. Okay, pi is a constant here, so don't worry about pi. So you have two dependent variable here, which is r, okay, and the second one is h. So you need to differentiate, okay, partially differentiate your v with respect to your r, okay, and then multiply with your rate of change for your r, okay, with respect to time. Okay, this by mathematically will cancel the r. Okay, so you will get dVdt. So dVdt is what we want, right? But don't forget you have another one which is for h. So you need to differentiate partially your volume with respect to h and then multiply with dH dt. So dH we cancel with del H we cancel with dH, so you just have dV dt. So summation of that will give you the overall volume changing, the changes of the volume. Okay, right, so first find dV del V del R. So concentrate at R. Okay, concentrate at R only and treat the others as a constant. That will give you 2 pi R H. Okay, and for del V del H, just concentrate on H and treat the others as a constant. That will give you pi R squared. Okay, so insert into the formula, you will get 2 pi R H times dr dt plus pi r squared multiply with h dt. You have all the information of the unknown here. So 2 pi r is 8 times with h 12 and your dr dt is 0.2. Okay, so make sure all the unit here are equal. Okay, so plus pi and then you have r square, which is e to the power of 2 and dHdt is 0.5. Okay, so multiply all this, insert into your calculator. So I will leave my answer in pi, so that will give you 70.4 pi. Okay, and the unit is centimeter cube per second. Okay, because this is in meter, cm, this is cm, this is cm per second. So that's why you have cm, 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 give you cm cube per second. Okay, so this is the answer for the changes of the volume. Okay, when the time increase. Okay, that's it. That is the calculation to find the changes for the volume, right? So now you know that for we can use partial derivative in order to find the increment, the small increment, and to find the rate of change. Right? So after this, we will look at more on the application of the partial derivative. Right? But before that, I will explain on the technique of partial derivative in order to apply the last application of partial derivative. Alright, see you again in the next video. Thank you.